In today's video, we are going to learn about plastic limit. It is one of the three Atterberg limit, that is liquid limit, plastic limit, and shrinkage limit. It represents the moisture content at which soil changes from a plastic state to a semi-solid state. This is the weighing balance, oven, spatula and glass plate, and the sample. Now, we start by preparing the sample by passing it through C425 microns. The soil must be clean and dry. When we have our sample ready, we can start the procedure. We now spread our soil sample on the glass plate. Then we add distilled water. Then we start mixing until we attain a homogeneous paste. So we add water little by little and allow uniform moisture distribution. So we continue mixing until it is plastic and moldable. The soil should be wet enough to mold but not excessively sticky. When you achieve that, take like 8 grams of the prepared soil and start rolling it on the glass plate. Roll the soil between fingers and the glass plate. Apply gentle pressure, not too much. Continue rolling until the thread reaches approximately 3 mm. Observe crumbling. When the thread begins to crack and crumble, it is at its plastic limit. Collect the pieces together and put it into 2 moisture cans because we'll need the average. Note that don't let the soil sample dry out before you test it or you weigh the wet soil sample. Also, applying too much pressure while rolling is not recommended. Only use the soil passing through the 425 micron seal. Number 4, take at least 2 trials to get the average. Then we put it in the oven and wait it for 24 hours. The oven should be at 105 to 110 degrees Celsius. After 24 hours, you remove the sample from the oven and wait for it to cool. So, what are the importance of plastic limit? These help us in soil classification, in foundation design, road construction, embankment construction, even predicting soil behavior during moisture changes. After our dry sample are ready, now we can weigh them so that we can have the values for the wet soil sample and the dry soil sample. That will help us to achieve what you need. That is the plastic limit. After we have the values of the wet and the dry soil sample plus the weight of the tin, now we can start our calculation. So we will just transfer our data from the book to the form. So we have our tin number as 3C and 3B. So the second column of 41.3 is the wet weight plus tin. The third column of 36 is dry weight plus tin. Then the third column is tin weight. So we subtract the wet weight plus tin minus the dry weight plus tin. We get the water. Then we subtract the dry weight plus tin minus the tin weight. We get the dry soil. Then we take those two. Water over the dry weight multiplied by 100. You get that 28.1%, and the second one is 28.3%. And then you add both of them, then you get the average. So our plastic limit is 28.2%. When we have the PL values, it will help us find the plasticity index in our next video, when we'll be having the values of liquid limit. Thank you for watching. Don't forget to like and subscribe and also share. Oh my